This was the topic we were discussing, I think, before the examination. Variation in ionic radius, how it varies in a group and in a period. So today we start a fresh topic. Chapter is same, so we have to discuss some trends. So on the modern periodic table. So let us go to today's session. What is there? Today's topic of discussion is ionization enthalpy. Enthalpy is a thermodynamical term. Timing we don't discuss in detail about the word, about the term enthalpy. Here for the today's session, we take enthalpy as energy. Both are same. Slight difference is there. That small difference we will understand in the thermodynamic chapter. Okay, right. So enthalpy is nothing but energy. Okay. So this is energy for ionization. What is ionization? To form ion. How ions are formed? Either by losing, or by gaining, or by sharing, or by coordinating some electronic transaction, some electronic business they do. So by doing that electronic business with someone, they undergo change. Because atoms are electrically neutral, we learnt equal number of protons and equal number of electrons. Equal number of positive charge, equal number of negative charge makes atom neutral. But when atom is busy, whether it is magnetic property, electrical property, reaction property, that time electrons are busy actually, because electrons are they revolving around the nucleus, so they take part in the most of the activities. So it is the electron which is very important, naughty particle, important particle, best particle. So electron number keep changing when the atom is busy. Sometimes an atom loses electron, gains, depend upon the situation, demand. What demand is there at that particular moment? So they take their own decision and they undergo change. Now, already I said an atom is electrically neutral, but when an atom undergoes what I said, electronic transaction, the time it will convert into what? Ion. So what are ion? Ions are electrically charged species. They develop charge. They get some charge, whether it is positive or negative. So when an atom loses electron, so what is expected here? Expected is what type of charge is created? It is a positive charge. Why? In the beginning, in an atom, number of P and number of E were equal. Now atom is losing electron. Okay. So electron number decreases. Proton number increases. Because proton number is increasing, it starts dominating. That means that charge is created. Which charge is more? That charge is created. And that too, how much more? How much more? One small example. Sodium, atomic number 11, 281, according to Bohr's theory. So this sodium wants to lose. First of all, why atoms wants to lose, gain, share, or coordinate? It is just because they want stability. How we want stability, comfortable, our own comfort zone. In the same way, atoms also wants to be stable. Stable means what? Chemically stable, electrical stable. So there are various stabilities explained on different grounds. So here stability means on the modern periodic table, we have extreme right side, one group is there, helium, neon, argon, that group, 18th group. If you see their electronic configuration, their shells are completely filled. So when they are completely filled, they neither accept nor gain nor share. So that type of configuration or the arrangement is called as what? Most stable electronic arrangement. That's why they are chemically least reactive. They don't want to lose. If you force them to lose by applying some drastic strong conditions, then only they undergo change. Otherwise, under normal conditions, they are least reactive. Why? Because they have that type of electronic configuration. Okay, what a configuration? Either if any atom having only one shell, K shell, if that is full, chemically least reactive. One more, if an atom having more than one shell, more than one orbitals, okay, that time if the outermost orbital is 8, if the outermost configuration is 8, that time also it is stable. So on two grounds we can explain the stability. Ground number 1, if an atom has only one shell, K shell, and if it is full, chemically least reactive. Ground number 2, if it is having more than two shells, but last shell should contain 8 electrons. If that is there, according to that ground, it is chemically least reactive or most stable. So this type of arrangement we will have only with these types of elements, helium to the radon. Okay. With other elements, with other atoms, we don't have this arrangement. You take any atom, sodium 281, lithium 21, nitrogen, it is atomic number 7, it is 2, 5. Nowhere you will get this type of arrangement. That's why they are not stable. They are active. They want to react compared to noble gases, compared to group 18th member. They want to react. So to react, either they have to lose or gain. No. So it is electronic. What is meant by reaction? Reaction means exchange of electrons. You give, I take, or you give, I give. Will go for sharing, or I don't have, you give me, or you don't have, I will give you. Okay. So some electronic agreement they go. So after doing some agreement, then they go for the bonding. When they go for the bonding, attachment starts, compound starts. Okay, so like this route goes in chemistry. So to acquire, to react, they want to go for electronic transaction. But how many electrons they lose? That is the problem. They are ready to lose. How many electrons are lost? How many are gained? That depends upon what type of electronic configuration it is having already. For example, sodium you take 281. Outermost contains only one. Now sodium is not having in a noble gas configuration, but it want to acquire that type of noble gas. Now for sodium, one more point here, other atoms wants to lose or gain to acquire this type of configuration. Why? That they are more stable. Now there are many noble gases on the right side, helium, neon, argon, but which noble gas configuration they acquire, that is the problem. So in chemistry, it is seen that all other atoms except noble gases, all other atoms, they want to acquire electronic configuration of the nearest noble gas. Which noble gas is near to its position on the modern periodic table with respect to atomic number of electrons, to that noble gas it want to acquire. So for sodium, it is 281. If sodium wants to become like neon, it has to lose just one electron, so that it becomes 2,8. Otherwise, if it want to acquire helium, it has to lose 1 and 8, total 9 electrons. Then only it become helium type. Or if it want to acquire the electronic configuration of argon 288, then it has to accept 7 electrons. So now there are 3 options: losing 9, accepting 7, or losing just 1. Which is easy? Losing 1. Always we see the shortcuts, short way, simple way, like that. So out of the three options available to sodium, sodium selects the one where it is easy. How it is easy? By losing just one electron. Therefore, sodium always prefers to donate or lose electron. And after losing, it becomes a positive ion. Because earlier sodium was having 11 protons, 11 electrons. Now after losing one electron, 11 protons are intact in the nucleus. But outside we have only 10 electrons. Okay, outside we have 10 electrons. So protons are more than electrons by 1. Protons are more than electrons by 1. That means positive charge is more than negative charge by 1. So who is dominating here? It is the positive charge. So they become positive. How much positive? How much more? 1. So it becomes plus 1. So sodium, after losing one electron, becomes sodium 1 plus. We write 1 plus on the head to represent symbolically. So sodium, after losing one electron, becomes sodium cation, sodium monocation, sodium 1 plus ion, sodium 1 positive ion. All those we can explain. So depend upon the need, depend upon the requirement, depend upon the situation. When demand is there, so they go for loss or the gain of electrons. Accordingly, they become respective ions. So after losing, atom converts into cation or the positive ion, and after gaining, atom converts into anion or the negative ion. For accepting an example is chlorine. These two are the most famous and the common examples we quote during ionization enthalpy. So chlorine is what? Atomic number 17. 287. So 287. So to become like noble gas, chlorine has to accept just one electron so that it becomes 288, or it has to lose 7 so that it converts into 28. But for sodium, accepting one is easy. Therefore, it wants to accept. Sometimes they ask question, why sodium prefers to donate? Why chlorine prefers to accept? It is because what? The type of electronic configuration they have. So sodium prefers to donate, chlorine prefers to accept. So after accepting one electron by chlorine, it becomes 288. Now, in this case, in the case of chlorine, protons are earlier 17, electrons are 17. Okay. Now, after accepting electron, protons are same because there is no change of proton number. Electrons are more by 1. So electrons are now 18. So electron number is more than proton number by 1. That means here, once again I said in the beginning for the positive ion, negative charge is more than the positive charge by 1. Therefore, negative charge starts dominating. So negative charge is created. How much? How much more? 1. So it is minus 1. So sodium becomes plus 1, chlorine becomes minus 1. In the same way, oxygen becomes minus 2, lithium becomes plus 1, fluorine becomes again minus 1, aluminum becomes plus 3, magnesium becomes plus 2. All these depend upon the electronic configuration. So to convert an atom into ion, atom has to lose or gain electron. But here we are discussing ionization enthalpy. This enthalpy is related to what? Related to become positive ion. Okay. So to become positive ion, it has to lose electron. So to lose electron, simply they will not lose. So you have to supply energy. Okay. So when you supply energy, okay, by some source, that time after accepting electron, energy by the electron, electron becomes more active. Already they have some energy, but you are giving some extra energy, no? So by taking extra energy, so they become more active. That time they will jump to next level. Please recall our Bohr's theory, K, L, M, N, O, P, Q, R, S levels. So if it is in L shell, it will go to M shell by taking energy. N shell, more energy. O, still more, still more, still more. Keep on giving more energy. Then a stage will come where that electron gets such energy that it is not now under the control of nucleus. It goes away from the area. That is called ionization. That stage. Which stage? A stage where atom loses electron. That stage is called what? Ionization, because ions are formed after losing. Okay, so energy required to remove electron from an atom to convert it into cation or a positive ion This is known as what? Ionization enthalpy. This is the IUPAC definition, International Union of Pure and Applied Chemistry. It is the organization where you have to follow rules of IUPAC in chemistry worldwide. Okay, so it is the amount of energy required to remove electron from valence shell of isolated gaseous atom. What is isolated? In the free. For example, sodium, it is solid actually. First, we have to convert sodium to the gaseous state. So, please take sodium atom, sodium solid to the gaseous sodium. So, now sodium atoms are free. Individual. In the solid state, they are combined because close packing. All the sodium atoms are combined in the solid state. Now, you supply energy. They become free. So, now they are free to move in air. That time, one you select, to that you supply energy so that that electron is knocked out. That becomes sodium plus ion. That is the way we understand. Okay. So that is called what? Isolated gaseous atom. Or the minimum amount of energy which is needed to remove the most loosely bound electron from a neutral isolated gaseous atom in its ground state to form a cation, also in the gaseous state, is known as ionization enthalpy. Lengthier definition. Here, what are the important words, important points here? Minimum amount of energy. So we have to supply how much is required. When we are hungry, we take how much we require food. We don't take excess also, we don't take less also. How much we require till we reach the satisfied stage or the saturation stage. That is called what? That is the minimum amount of food we require. In the same way, minimum amount of energy. Supply minimum, simply not waste energy. Okay, so supply how much is required because energy we have to produce. The entire universe is made up of only two entities, energy and the matter. It keep changing. Somewhere energy you have to bring loss, somewhere you have to gain. Somewhere energy disappears, somewhere appears. But total energy remains the same. This is called what? The law of conservation of energy. Therefore, let us not waste energy. How much is required will supply. That's why the important word is what? The minimum amount of energy. The minimum amount of energy which is needed to remove. Now next comes the most important point. The most loosely bound electron. In sodium, we have 11 electrons. Out of 11 electrons, are they same? Are they in the same shell? Are they bound to the nucleus in the same pattern, same way, same fashion? With same attractive force between the electron and the nucleus? No. It depends upon the distance, shell, everything is there. It is the 11th electron. It is the 11th electron in the sodium, which is most loosely bound to the nucleus because it's little far away. The more far away electron from the nucleus, less energy it has with nucleus. Okay, so that is what energy, that is the 11th electron having the least energy, or it is called most loosely bound electron. So to that most loosely bound electron, if you supply some amount of energy required, then it will come out. So our work is very easy, no? So with the least amount of energy given to the most loosely bound electron to knock out to become the cation, that is the ionization enthalpy. Okay, and because it is energy, so in what unit we measure? So energy is always measured in the joules. Okay, so ionization enthalpy is measured in joules. One more is here. In chemistry, to measure the amount of a substance, so normally we use one unit, that is what? Mole. Mole concept, no? Mole. So let's take 1 mole, 2 mole, 0.5 mole, 0.12 mole. So mole is the most important unit we use for measurement of chemicals. Therefore, we take 1 mole of any substance, then to that how much energy is required we supply, so that electrons comes out from 1 mole of sample. That is known as what? That is known as energy in kilojoules per mole. So ionization enthalpy is always measured in what? Kilojoules per mole. Please see the extreme right part. Atom has become cation. Okay, both in the gaseous state, free state, easy to handle. It is measured in kilojoules per mole, already told. Energy is always required to remove electrons from an atom, and hence ionization enthalpy are positive, most important here. That's why it is written with a different color. Whenever energy is given out, we use plus sign. When energy is taken, we use the minus sign. So this is related to the endo and the exothermic we learnt in the 10th class in short. But in 11th and 12th in detail we study. So whenever system gives out energy, that is taken as positive. Okay, it is given out. So system is giving energy to surrounding. That is called a positive. If the system gains electron, we are adding energy to the system. So system is in the high energy, so that becomes negative. Okay. So loss of energy, positive. Gain of energy, negative. These are sign conventions. Okay. Here don't apply mathematics here. Minus in minus sign, plus sign, adding, subtracting, no way connected. No way connected. Here a plus minus refers to what? Refers to the adding or the removal of electron. That's all. Right. Now see the left part, graphical representation. Okay. So they have taken a graph, that is ionization enthalpy in what kilojoules per mole. Okay. Versus atomic number, and you see the beautiful graph, zigzag graph. Okay. So most important area is what you see, the topmost and the bottommost. Topmost places are occupied by helium, neon, argon, krypton, xenon. All topmost. All these are noble gases. That means their ionization enthalpy is very high. Why? They are chemically least reactive. Fully filled electronic configuration. More energy required. So more energy is there on the graph. You see the bottom. See the bottom. Lithium, sodium, potassium, rubidium, cesium. Because they are the biggest in size in their respective periods. You take any period, first period, second period, third period. So in any period, these what alkali metals, they have the largest size. As they move from left to right, size goes on either decreasing or remains the same, never increase. So at the extreme left side, we have the largest size alkali metals in their respective periods. So when they have the largest size, then electron is far away. When the electron is far away, we require less energy due to less force of attraction. That's why they have taken the bottom place. So graphically also we can understand why the bottom place is going to the alkali metals, because their size is more, energy required less, so less energy, so they are bottom, more energy on the top. So extreme right, highest energy, extreme left, lowest energy. Which energy? Ionization energy or the ionization enthalpy. So all these you will understand. Okay. Now one more term. Successive ionization energies are the enthalpies. Successive. One by one. One by one. Okay. Removing one electron becomes plus one ion. Now I want to remove the second electron to become plus two ion. So step by step it is. Okay. So when we remove electrons step by step, 1, 2, 3, 4, and so on. Okay. That is called what? Successive ionization enthalpies. But normally we don't leave all electrons. Why? See, when we remove one electron, it acquires positive charge. Okay, now to remove the second electron, now it has to come out of the positive atmosphere. Already it was atom. After removing the one electron, it has acquired the positive charge. No, so coming out from the positive area by the negative electron is very difficult. It will come out, but difficulty is there. No, so we face some difficulties, some obstacles. So therefore, removal of second is little difficulty. Third, still difficulty. As you remove more and more electrons, we face difficulty more. Lot of energy expenditure is there. So that's why we don't remove normally more than 3 or 4 electrons. Maximum 3, at the most 4 or 5 under strong conditions. 6th, 7th, 8th, very difficult. It is simply waste of energy. Okay, so all these are called as what? Successive ionization energies are the enthalpies. So remove 1, remove 2, remove 3 is the ideal situation. More than 3, so we face challenges or why to waste energy. The same energy we can use for some other purposes. Okay, right. Here is the table. Okay, data to understand. First IE, second IE, third IE, and the fourth IE. So IE is the ionization enthalpy. So 3 examples I have taken: sodium, magnesium, and the aluminium. Okay. Now sodium, first IE 495.8 kilojoules per mole. You see second IE 4562. How much difference? My God. So where is 495? Where is 4000? First is in the hundreds. Second is suddenly thousands. So we don't want to bring such a large energy, it's simply waste. So supply 495.8 kilojoules of energy and just knock out one electron, it becomes sodium 1 plus. So sodium 1 plus is the divisible for the sodium to become 1 plus ion. So you see the third IE for sodium 7,000 range, 9,000 range, which is very difficult. Okay, sodium will not become plus 2, plus 3, plus 4 ion. Okay, plus 1 is the best for sodium. Now for the magnesium, you see magnesium 737 is the first IE. Second IE is what? Double, almost double. But from the second to third, you see large difference is there. So third IE is very difficult for magnesium. It can lose 1, it can lose 2. Third IE is very difficult for the magnesium. So magnesium will never become magnesium 3 plus. For magnesium, the best is what? 2. Why? Because magnesium's electronic configuration is what? It is 2A2. If it loses 2 electrons, it becomes a stable noble gas configuration. So happy. So 2, up to 2 allowed. That's why I have written one line drawn, red line. Okay. Up to that it is allowed. For sodium, only 1 is allowed. For the magnesium, 2 are allowed. For the aluminum, you see. For the aluminum, first is very easy. 577. Why? It is 283. So by losing 3 electrons, it becomes 2-8, aram se. Whereas by losing one electron, second electron, you see 1816. Third, just supply 2-7. Difference is not that much. Okay, you are not double also. Okay, but you see the fourth electron, it is in the 11,577 range. So sodium 1 best, magnesium 2 best, aluminium 3 best. That's why we have seen in the 9th class where under the table sodium charge is always 1 plus, magnesium charge is 2 plus, aluminum charge is 3 plus. Why? In the chapter where we go for the molecular formula, no? Aluminum chloride Al plus 3, Cl1 minus crisscross method AlCl3. But for sodium, it is not NaCl3, it is NaCl. Why? Sodium is 1 plus, Cl is 1 minus, exchange NaCl. So in the 9th class we learnt charge was there. Now why charge? Now we are understanding. Why that much charge only in 11th and 12th only we are understanding. So 11th and 12th is slightly specialized and the vast syllabus. So you have to understand how electrons are moving here and there. It is only electronic movement. If you understand the electronic movement, chemistry is understood. Okay. So I think I am going to wind up today's session. So till now, till successive ionization enthalpy, if at all any doubts are there, I am very happy to uh, declare, answer all your queries, questions. So most welcome to ask till now. Pallavi, any doubt? Please ask. Otherwise, I'll
Yes,
take
sir.
it. Okay, please. No doubt or yes doubt?
No doubt, sir.
Good, very good. So for me, the happiest
Sir,
moment is what? Yeah, please, please.
sir, symbol used for writing this ionization enthalpy, sir.
Delta H. H stands
Delta
for
S, sir.
enthalpy. That is a symbol we use in the thermodynamics. Hmm? Delta is what?
Okay, sir.
Difference in the energy. Okay. How much it
Okay,
was
sir.
having, how much is supplied. So the difference in energy comes out as energy in the form of wavelength. Hmm? So delta H
Okay,
is the symbol to write. So delta H equal to positive loss of electron. Delta H is negative gain of electron. Yeah. Anything?
thank you.
Sushmita? All these will come in the your NDA examination, UPSC. Hmm?
Yes, sir.
Mathematics up to 12th class, but chemistry only up to 11th class. Maximum 10th only. 90% he will ask from 10th only. 10% he will keep some of the 11th class chapters, especially structure of atom and chemical bonding.
Yes.
So be ready for the UPSC and the NDA entry.
Yes, sir, I am ready.
Oh, very good. So I think I take it as no doubts. Ramaling asked a doubt, or it's clarified. So further we will discuss tomorrow. We will continue this trend journey. Okay. So till then, don't sit idle. Always become active, either in the form of your physical fitness, walking, something, or study, mental fitness. So all those. So don't become idle. You become always active. So active members of science school, cadets. Okay. So till then, have a nice time, and thank you one and all.
Thank you, sir.
Thank you, sir.
Thank you.